Hello, welcome to a tutorial on how to use the probability calculator from GeoGebra, which is a mathematics software accessible online. In this video, we're going to use the probability calculator to solve some problems involving sampling distributions of proportions. Let's look at an example. Exit polling is a popular technique used to determine the outcome of an election prior to results being tallied. Suppose a referendum to increase funding for education is on the ballot in a large town with a voting population over 100,000. An exit poll of 200 voters found that 102 voted for the referendum. Once all the votes were tallied, it was found that in fact 48% of all voters voted for the referendum. We're going to use technology to compute the probability that, through random selection, one ends up with a sample of 200 in which more than 102 voters voted for the referendum. Trying to see, looking at this exit poll of 200 voters, it seems like it's just a random sample. What is the likelihood that we would end up with this sample, given the fact that, in fact, 48% of all voters voted for the referendum? Let's start just thinking about what information we have. So in this situation, the population, remember the population is the full group of individuals that we are interested in studying. This, in this case, is going to be all voters in the town. The population parameter is a characteristic of the population, something that has been measured from the population. In this case, it is the 48%. We know, in fact, that out of all people who voted in this election, 48% of them voted for the referendum. So the population parameter is 48%. And its symbol is P without a hat. The sample size is the size of our sample. So we can see from this information we have a sample of 200 people. So therefore our sample size, symbol N, is going to be 200. To determine what kind of sampling distribution we have, we note initially that we have categorical data here. Which we can tell because we're dealing with proportions. And also because if I think about an individual in the sample, it's one voter, and what we are measuring is whether or not they voted for the referendum. That is a category. Then we know that if the sample size times the population parameter is greater than 10, and the sample size times 1 minus the population parameter is greater than 10, then the sampling distribution for the population parameter P will be a normal distribution, with its mean being the population parameter, and its standard error, that is the standard deviation of the sampling distribution, that standard error will be this equation, the square root of the population parameter times 1 minus the population parameter divided by the sample size. So let's check and see if our situations, if we meet this situation. We need that N times P is greater than 10. So that means the sample size, 200, times the population parameter, the actual number from the population, 48%, needs to be greater than 10. 200 times 0.48 is 96. So yes, indeed, we achieve that first goal. And we need to check that N times 1 minus P is greater than 10. So we can check this too. 200 times 1 minus 0.48 is going to be 200 times a 0.52, that is 102, and 102 is definitely also greater than 10, so that checks out as well. Therefore, because I have categorical data and it meets this requirement over here, we can conclude that the sampling distribution will be normal. With the mean as the population parameter, so the mean being 0.48. Whoops, wrote the wrong symbol. Mean is mu. The mean is 0.48, and the standard error is going to be the square root of that 0.48, the population parameter, minus 1 minus the population parameter, over the sample size, following this formula right here. The population parameter times 1 minus the population parameter divided by the sample size. If we compute that, we find that it's about 0.035327. Make sure you don't round these as you do this calculation, or don't round it very much. If you rounded this to like 0.04, that would be problematic, and you very well might get the answer wrong. So be sure to not round intermediate steps. Now that we've got our sample distribution, we can use it to actually solve the problem. So we want to find the probability that through random selection, we ended up with a sample of 200 in which more than 102 voters voted for the referendum. This information that we have right here now, this is a sample statistic. It is telling us for our sample in particular, we found that 102 voters out of all 200 voters had voted for the referendum. 102 divided by 200 is 0.51. That is our sample statistic. And so what we are being asked for is the probability that we would have gotten any sort of sample statistic which has a in which more than 102 voters voted for the referendum. That means more than the sample proportion should be more than 0.51. So just to be clear, I am getting this more than, or I'm writing greater than because it says specifically more than the voters. I'm getting the 0.51 here from the fact that it was 102 voters out of 200. That's where the 0.51 is coming from. And I'm dealing with p hat because I'm talking about the sampling distribution of a proportion. This is the symbol for that. So to do this calculation, what I'm going to want to do is first, it helps to sketch the picture a little bit just so we can kind of visualize what's going on. I know the population distribution is normal, so I'm going to draw myself a little normal curve. I'm going to label the peak. The peak in this case is the mean. It is the population parameter, so it's 0.48. And I know that I'm interested in more than 0.51, so that means I'm trying to figure out the area that is above the point, specifically 0.51. To do this then, the next step is I'm going to have to go to my z-score. Remember, z in general is going to be like your observation minus your mean divided by your standard error. So in our case here, my z-score is the 0.51 that I'm interested in, minus the mean of the sampling distribution, which is 0.48, divided by the standard error that I have computed. Again, be careful about not rounding, or you can do this just all in one fell swoop in your calculator. That might be better. Doing this calculation, making sure that you subtract this first or put them in parentheses, we get that our z-score is 0.8492. All right, then once I've got that, my last step is to use technology to find the probability. I'm going to pull up my GeoGebra calculator, make sure that I am on the normal distribution, which is looking good with and I'm looking at the standard normal distribution because I'm dealing with z-scores. That means that I want to make sure that my mean is 0 and my standard deviation is 1. This is looking good. I'm interested in the greater than situation, so I'm going to select greater than. Then I'm going to highlight the box that is surrounded by the p because I am entering in my z-score, and I will type this guy in, 0.8492. All right, there we go. The answer on the other side then is my probability. So the answer in this case, the probability that I would get a sample that is larger, a sample proportion that is larger than 0.51 is in this case 0.197885. Or, doing a little bit of rounding, about 19.8%. What this means then is we're saying, all right, the probability that just through random chance I find myself with a sample in which more than, if I find myself a sample of 200 in which 102 voters or more voted for this referendum, when I know that in fact 48% of the voters voted for the referendum, the likelihood that I would be in that situation is about 20%. There's a 20% chance that this would happen by random chance. So the last question we might say, based on this result, would it be unusual to draw a sample that, would it be unusual to draw the sample that has more than 102 voters? And oftentimes 5% is kind of used as the cutoff point. So my options are either yes, there is a less than 5% chance of this happening by random variation, or more, there is at least 5% chance of this happening by random variation. And I've seen that the likelihood that I would have gotten this sample of 102 voters out of 200 by random chance is about 20%. So in this case, we would not call this unusual. There is at least a 5% chance of me getting 102 people saying yes out of 200 by just random chance. And this is an indicator too then that the process of exit polling, at least in this situation, was, fairly reliable. It didn't give me an incredibly unusual answer. So to summarize, in order to use the sampling distribution to calculate a probability, you need to identify what your population parameter is and what your sample size is. You need to make sure that you meet the requirements for a normal distribution, and then we have our formula, the mean and the standard error, to calculate what the sampling distribution is going to look like. To solve the problem, then, you sketch it. That helps. You find the z-score, then you use GeoGebra's calculator to compute what that z-score might be, what the probability would be, and then you can use that to make a decision. I hope you found this helpful.